All right, so, yes.
Can you use pen or pencil?
I prefer that everything be in pencil, but your notes are your notes.
Okay.
You can use whatever you want for your notes.
All right.
You take a quiz or a test or do homework, it needs to be in pencil.
All right.
Great question. But for your own notes, you can do whatever you want to do. Okay, part one. Some of you may have brought a calculator today and you may not have. But let's go ahead. If you did, go ahead and get your calculator out. How do we convert from a fraction form to a decimal form? What do I need to do in problem A? Divide. So 15 divided by 8. And the answer is 1.875. That is called a terminating decimal. Terminating because it stops, right? All right. Negative 11 divided by 6. Uh-oh. Negative 1.83333. That is called a repeating decimal. Both of these are rational numbers. Rational numbers are terminating or repeating decimals. Are there any decimals in the world that don't terminate and don't repeat? Or does every decimal either terminate or repeat eventually?
Eventually.
You know? Actually, there are, what? Pi. Pi is irrational. It does not terminate or repeat. Does anybody know any others that just keep going forever and ever and ever? How about the square root of 2 and the square root of 3 and the square root of 7 and the square root of 11? Those are all irrational numbers. Any square root that doesn't come out to be a number like the square root of 9 is 3, anything that doesn't do that is irrational. I know when you type it in on your calculator, it shows you a decimal, but that decimal actually keeps going forever and ever and ever. These are called irrational numbers. If the decimal stops or repeats, it is called rational. If it doesn't stop or repeat, it is called irrational. Did you guys study logarithms last year? Yeah. You said, ugh. Okay. Did you study ln logarithms, natural logarithms? No?
Yeah.
Well, if you did, you know the base of those logarithms is the number e. That is another irrational number. Don't worry about it. We'll talk about it later. These are examples of irrational numbers. All right. Describe and graph. We'll finish up this section real quick, or the first part of it. Describe and graph. What does this say? First of all, can you read it? X is greater than 3. X is greater than 3. Remember, the arrow points at the little one. You point at the little one. So this says X is bigger than 3. How do you graph that on a number line? We're talking about graphing it on a number line. How do we do that? Well, here's 3, right? And we put a circle and shade this way on the number line. Now, should I color in that circle? No. I would only color in that circle if we had this, right? So let's look at the next one, the next problem. How does this get sketched on the number line? We're going to have a negative 4, we're going to have a 2. No, you said it right. Negative 4 is less than X, is less than or equal to 2. These are both less than symbols. So that's how you would read it. Negative 4 is less than X is less than or equal to negative 2. But if you think about that, doesn't that mean X is between negative 4 and 2? Mm-hmm. So when I sketch it, I'm going to color in the area between negative 4 and 2. Oh, and the 2 circle has to be colored in because that's an or equal to symbol. Right? All right. Someone make a little notation there that that's where we need to pick up tomorrow, and we shall do that. If you want to bring your yellow sheet signed tomorrow, that would be wonderful. But it's not due until Monday. Maybe. I give bonus points when I feel like it.
You post notes on the schools, right?
No, they're on my website.